Okay, let's have a very quick look at the index laws. The first index law says that when multiplying indices with the same base, we add the powers. So let's say we have a to the power of m multiplied by a to the power of n. The answer will be a to the power of m plus n. So multiplying indices with the same base, we add the powers. Let's look at a very quick example of this. If we had a to the power of 5 times a to the power of 3, the answer is going to be a to the power of 8, because 5 plus 3 is 8. So that's the first index law. The second index law is essentially the opposite of the first. When dividing indices with the same base, we subtract the powers. So we use the same base, a, and we will divide a, and we'll use the same powers, m and n. So in this case, the answer is going to be a to the power of m minus n. So the first law, when we multiplied the same base, we added the powers, and now when we're dividing indices with the same base, we are subtracting the powers. So going with the same powers we had before, a to the 5, this time we're dividing by a cubed. The answer will be a squared, because 5 minus 3 gives us the 2, so a to the power of 2, a squared. That's the second index law. The next index law is the power of 0 index law. I'm not going to call it the third index law, because depending on who you're talking to, they might call this the third or the fourth or the fifth. It's generally agreed that the first index law is the multiplying indices one, and dividing indices is the second law, but after that, like I say, it depends who you're talking to. So another index law is the power of 0, and what this one says is that anything raised to the power of 0 is equal to 1. Let's take a look at 4 to the power of 0. Well, according to the law, the answer is going to be 1. But how do we get that 4 to the 0? Well, one way may have been 4 cubed divided by 4 cubed. Now, what did the second law say? When we're dividing the same base, which we have, we subtract the powers. So 4 cubed divided by 4 cubed is going to be equal to 4 to the power of 3 minus 3. Well, that's how we got our 4 to the power of 0, right? Grand. Now another way to write 4 cubed divided by 4 cubed would be like this. 4 cubed over 4 cubed. And we can see here, when we simplify, these are going to cancel out and leave us with 1 over 1, which is of course just 1. So 4 to the 0 is 1. And as the law says, anything raised to the power of 0 is 1. Well, I should actually point out any non-zero value raised to the power of 0 is equal to 1. Right, moving on, let's throw some brackets in there. A to the power of m. What if all of this was raised to the power of n? So a to the mth power raised to the n. What this is a to the power of m times n. So we're going to multiply the powers, the one inside the bracket with the one outside the bracket. As a quick example, a to the power of 5, if this whole thing were cubed, then that would equal a to the power of 15, because we're multiplying the 5 and the 3. So a to the 5th power, all raised to the 3rd power, is a to the 15th power. Now, staying with our brackets, another index law says that, in brackets, a times b, all raised to some power, is equal to each of those individual parts inside the brackets raised to the power. So in this case, it's equal to a to the m times b to the m. For a random numerical example, if we had 5 times 3, if this whole thing was raised to the 7th power, then that would equal 5 to the 7 times 3 to the 7. And if we flip the script and start talking about division, same deal applies. A over b raised to the mth power is equal to a to the m divided by b to the mth power. So that raised to the mth power actually goes to the a, and it also goes to the b. They've both been raised to that power, in much the same way as the previous example with multiplication. Now, if we have a negative indice, let's say we have a to the minus m, what this means is, what this equals is 1 over a to the power of m. So anything raised to a negative indice simply means that that thing is down on the bottom line. I actually use this in science a lot. For example, students might like to write meters per second. Now, I don't do this. I write meters per second because that s has been raised to a negative power, so that s is actually down on the bottom line, like our students would like to write it. S is down underneath. It doesn't matter what the power is, it's the negative part that puts it down. So if we were talking about acceleration instead of a speed, let's say we had meters per second squared. What this means is that s squared is down on the bottom line, so that's the same as meters per second squared. So that s to the negative 2 means that the s squared is down on the bottom line. So anything raised to a negative power, that thing is down on the bottom line as the denominator of a fraction. And to finish us off, fractional indices, let's say we had a to the power of 1/2. What this is going to give us is actually, go away, the square root of a. If we had a raised to the power of 1/3, this will be a to the 3rd root, so the 3rd root of a. So we have the denominator of the fraction becomes the root of the number or letter. Now, if the numerator isn't actually a 1, so let's get rid of that 1 there and we'll make it 2/3 instead. So our denominator, in this case a 3, makes it the cube root. Grand, that's still the same, but then we raise to the power of the numerator, so we'd have that. So the top number becomes at the end our power, and our bottom number becomes the root of the letter. And yeah, there you go. Index laws, a quick look.
Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.